So this video is on graphing inequalities, and inequalities are expressions that have less than, greater than, less than or equal to, or greater than or equal to operators. Now, if we have a less than or greater than sign, then we use a dotted line in the graph. If we have less than or equal to or greater than or equal to, then we use a solid line. And a few things to note is how to shade. If y is less than mx plus b, then we shade below the line because mx plus b is a line. If y is greater than mx plus b, then we shade above the line. And what ax squared plus bx plus c is a parabola. So if y is less than ax squared plus bx plus c, then we shade below the parabola. If it is greater than ax squared plus bx plus c, we shade above the parabola. And likewise, if we have a circle which is x squared plus y squared is less than r squared, then we shade inside the circle, and otherwise we shade outside the circle. Key thing to note is less than, greater than, less than or equal to, greater than or equal to. Less than and greater than would mean dotted lines. Less than or equal to or greater than or equal to would mean a solid line. So here we have our first inequality, and by the looks of it, this is a circle. And we know the general form of a circle is x minus h squared plus y minus k squared less than r squared. The equation is equal to r squared. H, k would be the center, and r is the radius. So for this curve, the center is at 2, minus 1. R squared is 9, which would imply r is 3. So we see a less than sign, which should indicate we have to draw a dotted line. And let's go to the center. X is at 2, and y is at negative 1. So the center is right there. The radius is 3. So I have 1, 2, 3. So that would be one endpoint. And 1, 2, 3 over here. And 1, 2, 3. And 1, 2, 3. Now all I have to do is connect this with a dotted line. And since we have a less than in the inequality, we have to draw it inside or shade it inside the circle. So, oops. So the solution would be all of that inside. Moving on to the next one, if we look at this equation, this is of the form y equals x squared plus bx plus c. Only in this case, instead of an equal sign, we have a less than sign. Less than sign should indicate a dotted line. And by the looks of it, this is a parabola. And it is simply a regular parabola that is shifted down by 1 unit. So we're right there. And you don't have to be perfect because we're simply wanting to know what the graph would look like. So since we have less than, it has to be a dotted line. And the solution would be everything below the dotted line. And keep in mind, inequalities have infinite solutions, and we shouldn't forget that. So every single point in the shaded part is a solution. So 2, negative 2 is a solution, negative 6, negative 4 is a solution. So that point is a solution, that's a solution, that's a solution, that's a solution. Every single one of them would be a solution. So now we have a system of inequalities. In other words, we have two different equations. The first equation is a parabola. Y doesn't have a square, x has a square. The second equation, if I rewrote it, I would have that, which would mean y. I'm going to multiply both sides by negative 1, so y would be less than or equal to negative 2 minus x, which would imply y is less than or equal to x minus 2. So both of them have an equal sign, so we are about to draw a solid line and a solid parabola. Since we have the line with slope 1 and the y-intercept is negative 2, I am going to put the y-intercept first, then negative 1, and I'd have 3 points. And since it is a solid line, I'm just going to draw a solid line. The next thing is the parabola. The parabola here is a regular parabola, which is y equals x squared, shifted down by 4 units. So we have when x is 0, we are at negative 4. When x is 2, we will be at 0. And the same at positive 2. Since we have an equal sign in the inequality, we are going to draw a solid line. And both of them have a greater than or equal to sign. So for the line, I'm going to shade everything above. And for the parabola, since it has a greater than or equal to sign, I'm going to shade everything above the parabola. So, or let me look at the terminology. They did use above and below. So above the parabola, so everything over there So the solution is actually the overlapping region. Which in our case is right over here, including the points on the line, because we have a less than or equal to.